In this example, we're going to find the difference quotient for a quadratic equation. In the previous example, we used a linear equation. Quadratic equations will make our calculations just a little bit more complicated, but the idea is still the same. We have a formula for a difference quotient, and there's three pieces: f of x plus h, f of x, and this h. We already have f of x, that's given to us in our original equation. And so the next thing we want to do is figure out this f of x plus h thing. So f of x plus h, we start with our original equation, but wherever there's an x, we are going to substitute instead our x plus h, because what we're really doing is we're taking our original input of x and we're substituting a slightly different number, one that's either a little bit more or a little bit less than our original input of x. So instead of x squared, I'm going to have x plus h squared plus 5 times, and now instead of the x, I'm going to plug in an x plus h. Now that we've put in our x plus h, wherever there was an x, we're going to go ahead and simplify that thing. Now the first thing that we want to do, because of their order of operations, we see we have an exponent, so we've got to deal with that first. So we need to take this x plus h and we need to square it. So if you'll remember your foiling, we're going to take x plus h and multiply it by itself. So when you FOIL that out, you're going to get x squared plus 2xh plus h squared. And so now all of that is going to get multiplied by this negative 2. So let's go ahead and write that back in there. And then we still have to add this 5 times x plus h. So let's go ahead and simplify that as we write it. So let's just multiply that 5 times the x plus 5 times the h. Now let's multiply this negative 2. Let's distribute it into our expression here. So we get negative 2 times x squared. Negative 2 times 2, so that's a negative 4xh. And then negative 2 times h squared, so we get minus 2h squared, plus our 5x plus 5h. Now let's scan across that expression. That looks pretty darn big. Is there anything that we could combine? And we look through it and we see, to our amazement, that there are actually no like terms to combine. So it turns out that this is actually what we have to work with, this huge long expression. Well, so now we do know what f of x plus h is equal to, and now that we know that, we can go back to our original formula, and we're going to substitute in what we've just found, and let's just go ahead and write that whole big thing out. So f of x plus h is going to be minus 2x squared minus 4xh minus 2h squared plus our 5x plus 5h. And now notice we've got a minus f of x, so minus, and then we go up to our original f of x, which is negative 2x squared plus 5x, and that whole thing is all over h, so all over h. Now on top it looks like we can do some simplifying. We can first of all distribute this negative sign. So writing this huge big thing again, negative 2x squared minus 4xh minus 2h squared plus 5x plus 5h plus 2x squared minus 5x. And once again, we can't forget that all of that goes over h. Let's see what we can do to simplify here. It looks like we've got a negative 2x squared and a positive 2x squared, so yay, we can get rid of those. And what else? We've got a plus 5x and a minus 5x, so when you add those two together you get zilch. So that looks like about all we can do to simplify. So let's just rewrite what we've got here. Negative 4xh minus 2h squared plus 5h all over h. Now we need to figure out, can we simplify that thing anymore, or is that our answer? Well, it turns out if you look at the top, you see that there are h's in all of the pieces. So that means that we could factor out an h, and then that h could cancel with the h that's on the bottom. So let's go ahead and do that. We are going to factor out an h from each of the pieces. So h times minus 4x minus 2h plus 5 all over h. The h's cancel. And now we are finally at our answer, negative 4x minus 2h plus 5. So again, it's the same idea as what we did in the previous example with linear equations, but it's just a little bit more complicated, takes a few more steps to get to the end.